So in this video I wanted to talk about a very long video I saw in the past, which is called "What is a number?" from Another Roof. In this video he asked the question, okay, what is a number? Also what is the essence of a number? He gives the example here that, for example, we know those things on the right are green, those things on the left are red, but what is that in the middle? How do we define red? And we normally take wavelengths and say, okay, that is red and that is not red. And we separate therefore the red from the non-red by pointing at something that we have defined to say, okay, that is red and that is not red. But he says, well, we don't have that for numbers. We have our intuition. We know what the number is, right? The number is just multiplying certain numbers over and over, or basically multiplying sets together and counting all the content of all the sets together, and that is basically then our end number in the multiplication here in this example, right? But what is the things that we are counting? What is the things we are actually putting together, right? He then talks about different units of measurements, PSI system, the other things like moles, kilograms, mass, kilogram, right? He says basically for each unit, we have something in the real world we can point to, which we have defined and say, okay, that's it, right? So if I want to define a kilogram, in the past we had a mass. Let me show it again here. Right, we had a mass, so we can point to that mass and say, okay, a kilogram is that mass and it's nothing else. And basically he wants to do this for numbers too, because we don't have this. But he later on jumps to an example which I will get back to. But right now we go to how he says we could define numbers by basically saying, okay, there's a thing and this thing is 1, then there's 2 times this thing, so it's 2, then there's 3 times the thing, that's 3, and then there's 4 times the thing, there's 4. And if you want to count, we just see if the things we want to count is equal to the set of the things, right? And if you think about this, this is the most sensible thing to do, right? But he wants to go abstract. And the question is, why? Why does he want to go abstract? Well, because we don't have infinite numbers in the real world, but he wants to have something that can indefinitely be repeated to contain all the numbers. So after a long explanation about sets, which I will jump, and some dubious philosophical ground, he comes to the final conclusion that these are numbers. That this represents 1, that the smaller box in a bigger box represents 2, that this complex of a bigger box in a smaller box with another smaller box is 3, and so on and so on. But what did he actually has in these boxes, right? Because those are sets, those are differentiated. Well, he has in those sets nothing. Now, which type of nothing? And here's the thing, and we go for this to the video where he talks about if things exist, he can make groups out of it. So we now assume that he describes with his balls all things that can and could exist, right? And so he can group the categories. He also makes a category for nothing. And because he talks about things that could exist, then he means absolute nothing. Now, this is a problem because absolute nothing is, well, absolute. Meaning this one box here, this one little red box is absolute nothing. Then we have absolute nothing in absolute nothing, which is, well, absolute, so it's still absolute nothing. It's undifferentiated. He basically makes a trick by making the unit which counts the sets, right? So you could say, well, this absolute nothing turns into the absolute thought. So he basically counts not nothing, but thoughts. So he says, okay, this is 1 thought, these are 2 thoughts, these are 3 thoughts, these are 4 thoughts, right? And he counts the numbers on the thoughts, not on the content, because the content is absolute nothing and indifferentiable. Meaning what he does is he has thoughts, but more important, he has different thoughts, right? So he has an absolute thought, which is still undefined, different from a different thought, which is still absolute undefined. And that's the problem, because it doesn't matter if we use absolute thought or if we use absolute nothing, we still get no differentiation because those things are absolute. So what we have is we need to fill the content of the thought with something. And he does this by making those boxes, right? The idea of a set is what fills the absolute thought, which differentiates it from other things. So we can only count on here because if we think about the small red box, this is one thought. This is one, right? If we think about the blue box, this is a different thought, which is different from the original one. And we also know that a blue box needs to contain a red box in it. So it's 2 times itself, because we can just say, well, it's 2 boxes. And that is literally it. So we have a thought about this small little red box, which is equal to 1, right? So we're thinking about the red box. We're thinking here specifically about a box. This is what it makes it 1. This is the content that fills this thought, that matches define. Then we have a different thought where we think about 2 boxes, right, which needs to be in each other. This then defines 2. Then we think about 3 boxes, which in this complicated arrangement have to be in each other, which represents 3. He literally could just move this away and it would not change anything. The rule just have to be that the box has to be inside a box and different colored for the mind to remember this. But yeah, it's just have to be different in terms of thought, in terms of content, in thought, right? And then we could do this as for the same fourth box here. And then we see that the true thing we really do is we don't count on the boxes, because the boxes are absolute nothing or absolute thought, and damn it, not countable, and not even not countable, we cannot even compare to them. Like, imagine you have a pool of water and you make subgroups into this pool of water. How are we gonna measure a thing? Do we just take the 3 pens and put them randomly in areas where we have defined groups for those pens? No, of course not. So what we do is not measuring by his absolute nothing groups, which basically also mean absolute nothing. But what we do is we have thoughts that contain a unit that repeats itself and contains always itself, similar to his absolute nothing, but this unit actually is in conjunction to something in reality, right? For example, if I have 1 ball, then this is 1 thought. If I have 2 balls, then this thought contains the original thought, like the sets, and therefore I can say these are 2 balls, because it contains the other one, because it contains also the element of the other one basically twice, because I have 2 balls. We can therefore say this is 2, count to 2. That's why it's intuitive to us. So the problem here, and why this is absolutely not on rock solid bedrock or something, is that we cannot do anything with it. Right? He can make this definition, but this is only in his head. We cannot compare anything to what he has built. We cannot point anything towards it. He has to build the thing. And in this case, he has not an abstract anymore. He has absolute items, right? He can make rules in a system, and that is all fine and good, right? So but again, similar to the steel, we have in the real world an absolute object which we need to point to, on which we can count. We cannot count on something absolute in our head. This is impossible. If like, the thing is, the only reason why logic even works is because we can talk and we can unify the concepts in the head into one thing. If everybody would count anything with different names, with different attributes, with different things, it would be impossible to do anything. So we need to unify our thoughts. We need to say that a certain thing is thought about in a similar way in each other's head, so that logic even works and we can discuss. So the only reason why, for example, we can understand his example is we already intuitively know what numbers are. If we would not intuitively know what numbers are, we would not understand his example, because intuitively he has created nothing. He has shown nothing, he has separated nothing, and made a system that isn't really makes sensible. Right? He has basically repeated itself, the small boxes becoming bigger and bigger. But again, if we cannot comprehend numbers, because we may be only thinking one thought that's constantly changing, then we have not learned anything from this example, right? So this is my deep critique of his of his idea of the numbers, that he uses absolute thought, saying about the absolute nothing, trying to describe something which he cannot describe in absolute terms, because we need to count to something, or beziehungsweise we need to point to something in the real world to even count. And if we cannot do this, then thought would be absolute, undifferentiable, and thus we could not count. So yeah, this whole thing just doesn't work, and I hope it was understandable. Now, another pointing out is the idea that those infinities, now we change the subject here, he brings it for some reason up in this video as an example, that he has two sets, one containing all the numbers and one containing only half the numbers, and asking us which set is bigger. And then he says, well, because we can pair those two numbers all, they are actually the same size, which is not true. This is why the video is bad, because the reason why this is not true is because he's confused about what he means. Because he talks here about sets, he does not talk about the number in its size, right? So 1 and 2 is, for all means and purposes, the same, because it's one number. This is what it means here. So it talks about the number of content in those sets, right? Now, if he says, well, the left set contains all the numbers, and the right set contains only half of those numbers, then logically the left set is bigger. The trick then uses to fill those holes and basically to put 2 at the position 1 of the number line, to put the 4 at the position 2 of the number line, the 6 at the 3, and so on and so on. So basically take the original number line, multiply it by 2, which doesn't matter because we only go with the numbers of elements, and then compare them. So he basically says, well, look, here we have a number line of 1 to 3, and it's exactly the same as the number line of 1 to 3 multiplied by 2, which is correct, but this is not what we're talking about. We're talking about a set which has holes in it, and you have filled those holes out of infinity and make the set equal, right? But what is infinity? Well, infinity is an infinite process. So if we think about infinity not as an absolute term, which mathematicians really sometimes like, and then get them to genius results like 1 plus 2 plus 3 and so on, so on, so on, creates minus 1 over 12, which of course they know is not the correct result, but it comes up with, I think, the gamma function, not the gamma function, some function which is not defined into as a negative. There the number comes up, so it comes up with some absolute infinities, really weird thing. But what he basically tried to do is he takes infinity, he makes infinity absolute as by finishing the process and then compare the results, which again is difficult to do because we have to talk about the real thing, right? Or about the similar thing. Right? Infinity, again, is an infinite process, and you cannot always just say, well, it's done, because what is, for example, 1 plus 2 plus 3 and so on in infinity? Well, we just say, well, it is the number infinity. Technically, it's kind of not true. It's just ever growing. But let's go back to the original example. What we basically have to keep in mind is if we talk about a set that is infinite and has to grow. So if you talk about the sets of the real number line, it needs to constantly grow one number at a time, right? But if we talk about the set about only half the number lines, then the set grows only half a number at a time. Or in other words, for every 2 numbers the left set grows, the right set only grows by 1 number. Thus the growth rate not the same. And because they're not the same, the sets are not of the same size. And the trick to only pull from infinity to fill all those gaps and then say, well, the set are actually the same, is something that is just not correct. They're just holes in the cheese, they are there and they cannot be filled. They should not be filled, right? Because this just changes the result. This is similar to a different example where, let me remember it correctly. It was something like in one box, one ball was put in. I think it was 4 balls, something like this. Was like 5 balls were put in, but 4 balls were taken out. Nah, I cannot remember. Sadly, I cannot remember. But okay. So the critique here is that he uses a different type of infinity. Well, this type of infinity, this type of absolute infinity can be used, and in fact it is used, for example, in proving that 0.999 infinity is equal to 1, right? This makes this an absolute infinity sense, right? Because basically the difference between both 0.999, right, and 1 becomes smaller the more 9s we add, right? So the limit of using the infinity here goes to 0. Because the limit goes to 0 and the difference goes to 0, we can say, well, the end process, it has to be 1, right? If infinity is finished, it has to be 1, and that makes sense. So in the limit, we can say, yes, 0.999 indefinitely ended where the process has ended is 1, right? So if we could see the complete set, which is ever growing, but if we could completely see the complete set of that, it would be equal to 1. That makes logical sense. But here is the problem again, because both sets, the sets of all numbers and all half the numbers, have different growth rates, the limit or the difference never changes at all, right? It will always be the left set is 2 times bigger as the right set. So anytime they grow, it's just always the same difference. Meaning, in the limit, nothing changes. Meaning that using the absolute infinite and then changing the results by filling the right box is just not correct. So yeah, this example which he's saying is it's not correct, and intuition is correct. The left is just bigger, right? So basically, this entire video is just saying absolutely nonsense, and yeah. I hope that he sees this, that he understands my critique, and kind of maybe writes a comment. Yeah, that was for the video. I hope you enjoyed it. Bye.